So first, what is the redox reaction? The redox reaction, or what we also can call it oxidation reduction reaction, is a type of a chemical reaction. This reaction involves the transfer of electrons between two species. One of those species would gain electrons, the other part would lose electrons. So if my reaction involves the presence of oxygen, this means part of my reaction, what happened to this part is an oxidation. The oxidation is actually the gaining of oxygen. If I looked at this reaction, you could see that magnesium reacted with oxygen and gained oxygen and to form magnesium oxide. So magnesium in that case has been oxidized due to the gaining of oxygen. On the other hand, if the reduction would be the losing of oxygen in reactions that involves the presence of oxygen, example for that, copper oxide would just react with water, and what will happen is the losing of oxygen by the copper and the gaining of oxygen by the hydrogen. This means the copper in that case has been reduced due to the losing of oxygen, but on the other hand, the hydrogen have gained oxygen. This is why I will consider the hydrogen to be oxidized. Let's look at this exercise. In each of the following equations, state which reactants had been oxidized or had been reduced. I have here lead oxide that reacted with hydrogen to form lead and water. You could see that the lead have lost the oxygen and the hydrogen have gained oxygen. This is why I will consider the lead to be reduced, and on the other hand, the hydrogen is oxidized. Let's look at another chemical reaction, and here I have carbon monoxide that would react with I2O2, and in that case, what happened? I have here oxygen and I have here oxygen as well, but you could see that I have increased the number of oxygen atoms on this part, and here it in that case it lost oxygen. So this is why I will consider this part, which gained more number of oxygen, to be oxidized, and that part have been reduced because it lost oxygen. But if I don't have oxygen, how can I know if I have redox reaction? So can redox reaction happen in presence of oxygen? Yes, of course it can happen, and so we can even know if there is a redox reaction or not by looking at the electron transfer. So I would look at the reaction. If there is any electron transfer, I will consider my reaction to be a redox reaction. Also, if there is any change in the oxidation number, I will consider my reaction to be a redox reaction. Let's look at this example. In here, I have redox reaction which doesn't involve the presence of oxygen. On the other hand, it involved the presence of electron transfer. This is why I will consider this reaction to be a redox reaction. So when sodium reacts with chlorine to form sodium chloride, in that case, a redox reaction happens, and a loss of electrons happens to my sodium, and the gaining of electrons by the chlorine happens. Let's just divide my reaction into two parts. In the first part, in that case, I would look at the sodium, and you could see that the sodium would just lose the electron in the outermost shell by giving this electron to the chlorine. So in here, the sodium atom will lose electron and transfer into sodium ion, and I will have here electron. We can also write my reaction in that case sodium minus 1 electron to give me sodium ion. So what happened here is a loss of electrons. This is why I will consider the sodium to be oxidized. So the oxidation would mean in that case not the gaining of oxygen, but on the other hand the loss of electrons, and we can just abbreviate that to OIL. And when we say OIL happen to sodium, this means oxidation due to the loss of electrons happened to the sodium. Now this half equation would show me that the sodium is oxidized, but what about the other part which involves the chlorine? So I have here the chlorine atom. Actually it gains each chlorine molecule would just gain 2 electrons to form chlorine ions, 2 chlorine ions. So if I divide this reaction by 2, each one chlorine atom would gain 1 electron to form chlorine ion. This means the chlorine in that case have been reduced. It gained electron. it gained the electron, and this means what happened is RIG, which is the reduction by gaining electrons. So you have here the sodium again and the chlorine. The sodium will be transferred into sodium ion by losing electron and being oxidized. On the other hand, what happened to the chlorine is forming the chlorine ion, which means it have been reduced due to the gaining of electrons. So oxidation means the loss of electrons, and reduction would means the gain of electrons. So let's look at this example to see which part have been reduced and which part have been oxidized. In here I have iron which reacted with copper to form iron ions and copper metal. In that case, if I wrote down my first half chemical reaction, which involves the iron metal losing 2 electrons to form iron ion. In that case, if I looked at this reaction, you could see here what happened to the metal iron is losing of electrons. This means oxidation have happened to this part. The second part of my reaction involves the copper ions, and the copper ions took these 2 electrons and transferred into copper metal. So what happened here actually is a reduction for the copper. So the copper have been reduced, but the iron have been oxidized. When I look at the chemical reaction, in that case of the redox reaction, we have to do what is called balancing my chemical equation to know the number of electrons that have been transferred from one species to the other. In here I have the nickel, and the nickel in that case lost 2 electrons and formed nickel ions, and I have the other part, which is the iron, took one of those electrons to form a least oxidized form of my iron. So in here what happened is actually an oxidation, and here what happened is a reduction. But you have to remember one thing. In here, what happened is my iron, instead of being oxidized to the oxidation number being 3, it been reduced to 2. This is why it been reduced. This means a reduction have happened to the iron. So if I looked at in that case, I had 2 electrons from the first reaction. So to be able to balance my chemical equation, I need to multiply, because each iron ion is actually gaining 1 electron, gains 1 electron. This is why I have to multiply this equation, the second equation, by 2. And in that case, when I multiply it by 2, I will have 2 iron ions that will gain 2 electrons, because I have to multiply here by 2. So I have to multiply just the whole equation by 2. So here the iron by 2, and in that case I will write down here multiplying by 2. This means I will have 2 reduced iron ions. So this is what we call a balancing chemical equation. If I have the first equation, which involves the presence of 2 electrons, this means in the second equation I have to make sure that those 2 electrons have been taken by the second species. This is why I had to balance the other part of my reaction by multiplying the second reaction by 2. The balanced ionic equation in that case, a summary for that: the nickel reacted with the iron ions to form nickel ions and a least reduced form of my iron. And you could see that in here I have 1 nickel atom, and in that case I have 1 nickel atom. This is the oxidation number. It doesn't involve the presence of another nickel ion. It's just involves the oxidation number. But I have here 1 single atom, and then 1 single ion, and then here I have 1 single atom. In that case, I have 2 iron ions, and in here I have 2 iron ions. So you could see by that we balanced our chemical equation, my ionic chemical equation, because in here I have the same number of this species, the nickel species, and I have here the same number of iron species on both sides of my redox reaction. By that we came to the end of our first part. In the next part I will show you how to calculate the oxidation numbers of any redox reactions. Until next part, thank you and goodbye.